finding the volume of prisms and cylinders. And then tomorrow we'll do the volume of pyramids. When we talk about volume, we're thinking about like space inside. So like if like a water bottle, common example, is like you can have your volume inside your water bottle, like how much space there is in the inside of something. So we could find like in a prism here, what's the space on the inside, how many it's going to be cubic units because of our formula. So the formula for the volume of a prism is V is equal to B times H, where B stands for the area of your base and H is the height. So the volume, it's units. Units for volume are units cubed. Because if we take the base times the height, the base is an area. So our area and U will be units squared. And height will just be a standard unit. So whenever we're writing units for volume, it'll always be volume cubed because this is like unit to the first power. So 2 units times another unit would be units cubed. So how they came up with this formula to find the volume is by taking cross sections. So we start with our base, and if we look at the base, it's a square, and it's a square all the way up. So if we take the area of this base and kind of just keep stacking it on top of each other in squares like this, and then say we stack another square, but we're stacking the squares so they're right on top of each other and there's no space in between. If we stack those all the way up, we can find our volume. Same thing even if our shape is slanted. We're stacking still squares all the way up. And sometimes if your figure is at an angle, you'll see kind of a right triangle drawn off of it because you don't want to measure diagonal heights up and down. All right. 2 other things that would be good background information just to know. We'll be using a lot. Area of a triangle, 1/2 base times your height. We've done that a lot this year already. And also area of a square or a rectangle is your length times your width. Both of those we'll be using today. So our first example 1A, we're finding the volume of a triangular prism. So first thing you always have to do is figure out like what shape is your base. Where our base here, if we stack up, it's a triangle. We can make a bunch of triangles in here. Think like layers of a cake. Each layer is a triangle. So we take the area of this base, multiply it by how high we're going, we're going to get our volume. So we're going to find the area of our base, so area of our triangle is 1/2 our base times our height. So our base of our triangle would be 3. So this is our right angle. Our base is 3, and our height is 4. So this is 1/2, 3 times 4. So 3 times 4 is 12. We split that in half. That's 6. So area of our base is 6 centimeters squared. And then we plug that in for our B value. So to find the volume of our full thing, volume is equal to the base times the height. 6 centimeters squared is going in for our base. And we know that our H value is 2. That's how high we're stacking it. So we'd say this is equal to 6 centimeters squared times 2 centimeters. and that's equal to 12 centimeters cubed. So whenever you're figuring out what is your base to stack it, it has to be the same shape that makes it all the way up. So if we were to use that side of our triangle that is a rectangle and use that as our base, that wouldn't work because we do it in like 3 dimensions. We would make a rectangular prism when we would want a triangular prism. All right, we need to cut it out with the side conversations. It's disrespectful and rude. So next example, our base now, it's not a rectangle, it's not a triangle, but it's a trapezoid. So on the bottom here, we're going to have to layer up this trapezoid shape where we have this side and here. We don't know how to find the area of a trapezoid, but we do know how to find the area of rectangles and triangles. So I would split this shape up, our base, into 2 triangles and a rectangle. And that we can use for our B value. So we'll do the area of the 2 triangles first. We need to find the base and the height of each of these. So this, with the double dash mark, that's going to be the base of our triangle. And if we know that the whole top section, we know this length is 14, that means this whole length is 14 as well. And 6 of it is taken up by this rectangle in the middle. If we do 14 minus 6, we can get our leftover space for our 2 bases. So 14 minus 6 is equal to 8. And we have to split that 8 up evenly into both of our triangle bases. So 8 divided by 2 is 4. So that means the base of this triangle is 4, and the base of this triangle is 4. And then we know that the height of these triangles, all these lengths are the same. And we know that's 3. So our base is 4 and our height is 3. So we could find the area of at least one of the triangles. 1/2, 3 times 4, or 4 times 3. So again, that's 6 centimeters squared. But since there's 2 triangles, we have to double it. So altogether, the area of our region in red is 12 centimeters squared. So we have to double 6. And I'm going to dash circle that because I know that's like an intermediate answer that I'm going to use. All right, so now we could use the area of that rectangle. That's our length times our width. That's equal to 6 times 3, because we know our length is 6, our width is 3 from our diagram up here. So that's 18 centimeters squared. So when we combine those 2 values together, we'll get the total length of, the total area of our base. So our volume is equal to our base times our height. And our base we get from adding 18 and 12 together. So 18 plus 12 is 30. So we say this is 30 centimeters squared times our height was 5 centimeters. So this would be 150 centimeters squared then for the area of this prism, centimeters cubed. We get this from 18 plus 12. In case you missed that part. All right, we'll keep going. So example C, again, think of, your question is, what is your actual base? If you were to use your base of the square and stack it up, you're not going to keep the shape. You'd get a box. We don't want a box. You want like a slice. So we have to use a triangle and kind of push it through our figure. So we're making slices going down this way. A bunch of those slices. So our area, or our B value, is the area of a triangle. So we'll say A is equal to 1/2 of our base times our height. Our base is 5, our height is 8, so this is 5 times 8. So this is 40 divided by 2, which is 20. So this has an area of 20 centimeters cubed. Sorry, squared. Jumping ahead of myself. Not cubed yet. 20 centimeters squared. Again, that's a halfway answer. So then we use our formula for volume. Base times our height. We found the area of our base. That was 20 centimeters. And then our height, even though a lot of times we think of height going from like top to bottom, height, now we're kind of pushing through 3 centimeters. Same thing, if we were to lay this on its side, the height would then be 3, since it's a 3-dimensional figure. So this is 20 centimeters squared times 3 centimeters, which then gives us 60 centimeters cubed. All right. The D gives us another problem where our base, we can't use like what it's laying on as our base, because if we use this rectangle shape all the way up, we're going to lose this slant as part of our volume. So our base is going to be our slice that goes all the way through our diagram, this kind of rectangle and then a tiny triangle on it. So we're going to find the area of 2 separate polygons and then combine them. So we have this triangle here, and then we have a rectangle. So first, let's find the area of our triangle. We need the base and the height. We know that the height will be 2.5. To find the base, we could take the longer side minus the shorter side, so 5.6 minus 4.4. And that will give us 1.2. So that's the length of this right here, 1.2. So then we take area is equal to 1/2. Our base of our little triangle is 1.2. Our height is 2.5. So then we use our calculator to do that. 1.5 times 2.5, let's split it in half. What did I mess up? 1.5. Why is my number so small? It's not height. 1.2.
What if you do what you did with the other one, the other base? Like you take 4.2 times 5.6. Or something like that for your base.
Oh, I just typed it in wrong. That's what I did. All right, so it should be 3, and then divide by 2, so it'll be 1/2. Classic. So this is 1.5 centimeters squared as our area of our triangle. And then let's do the area of our rectangle, so what's in our shaded region there. So our length would be 4.4 and our width would be 2.5. So 4.4 times 2.5, 11. So then our combined area, or our base, would be 12.5 because we have to add those two together. Right, so this is we found our B value, so 12.5.
Did you find the volume separately? Do the volume of the triangle?
Yes, you technically could do that. That seems like it would be more work though. But yeah, you could. So 12.5 times your height, and your height again is kind of like we're pushing through our figure, so it's 4.2. So this is times 4.2. Oh, this is meters, not centimeters. I'm all over the place. Meters squared. It's meters squared, meters squared. This is meters. 12.5 times 4.2, 52.5 centimeters cubed. Meters cubed. I don't know why. I'm a big fan of centimeters, I guess. Meters cubed. All right, so that's prisms. Prisms are the more difficult because you can have more than one shape in them. If you flip to the back, cylinders really quickly. Your base of your cylinder will always be a circle. So it's still base times height, but for base, it's always going to be pi r squared. So for this first example, now we're taking like our layers, our circles, and we're stacking those up. So the area of our base, pi r squared, of our radius is 9. We square 9, it's 81. So this is 81 pi is our area of our base. And then to find our volume, we plug 81 in for B, and then our height is 6. So we multiply by 6. So 81 pi times 6. Pi times 6, we get out